Good morning, everyone. I am Dhruti from Venkateshwara College of Engineering, CSE department. I will give a small presentation on Finders algorithm in machine learning. Let's move to the introduction. The Finders algorithm is a basic concept learning algorithm in machine learning. The Finders algorithm finds the most specific that fits all the positive examples. We have to note that here the algorithm is going to consider only those positive examples. The Finders algorithm is going to move from most specific hypothesis to the most general hypothesis. Finders algorithm, it is a simple machine learning algorithm which will come under supervised learning task. This algorithm will assume that there is a more specific hypothesis which is going to explain all the positive instances in the training set. For example, we are going to have a training set, and from these hypotheses, from this more specific hypothesis, we can explain all the examples, positive instances, and it is not going to consider the negative instances. It considers only the positive instances. Let's move to the representation, how the representation of hypothesis is done. The question mark is going to indicate that any value is acceptable for the attribute, which means the question mark simply tells that whatever the value you give for the particular attribute and that is accepted. And phi indicates that no value is acceptable, which means no value for that particular attribute cannot be accepted. And we can see the representation of the most general hypothesis and the most specific hypothesis. The most general hypothesis is specified by a question mark and the specific hypothesis is specified by a phi. And the number of question mark inside the flower braces will depend upon the number of attributes that will be given in the training data set. This is about the representation of the hypothesis for Finders algorithm in machine learning. Let's see what are the steps involved and how it works. First, we have to give the most specific hypothesis. That is, as I told before, that phi value will be given according to the number of attributes that will be given in the training set. Then next, if it is negative, there no changes occurs to the hypothesis. It will remain as it is. First, we have to consider the most specific hypothesis, and if it is a negative and no changes occurs, and if the example is said to be positive, then we should take our initial hypothesis that is specific, and we can update our current hypothesis to a general condition. You have to keep repeating the above steps till the training examples are completed. After we have completed all the training examples, we will have the final hypothesis when can use to classify the new examples. So the Finders algorithm, where each attribute value can be specific or a wildcard, that is the question mark. The hypothesis is represented as a conjunction of attribute values. So first, as I told, the algorithm will start with an initial hypothesis, that is the first positive instance in the training set, and it is going to iterate through the remaining positive instances in the training set. And for each positive instance, the algorithm is going to update the hypothesis by replacing any attribute value that is inconsistent with the positive instance with the question mark. The updated hypothesis is then used as a hypothesis for the next positive instance in the training set. And it simply tells that first we have to consider the most specific hypothesis. The most specific is nothing but the phi value, and for each positive example you're going to consider a positive example, and for each and every attribute we are going to check if that value, if it is equal to the hypothesis value. In that positive example, in that attribute, if it is equal to the hypothesis value, then you're going to ignore it. You're not going to make any changes. If that value, if it is not equal to the hypothesis value, then you're going to replace it with the most general hypothesis, that is the question mark. So this will iterate through all the positive examples. So this is about the steps involved, how it works or how it executes. Let us consider the example we are having a data set which is having about the information about the particular seeds which are poisonous or not. So first instance we can see here they have given with the color, toughness, fungus, appearance, and poisonous. This is a poisonous is the target function. So they have given us green, hard, no, and wrinkled. Second instance with the green, hard, yes, smooth, and the attribute values may change, and no is the outcome. Brown, soft, no, wrinkled. That is the third instance. Fourth instance is the orange, hard, no, and wrinkled. Fifth instance is the green, soft, yes, smooth, yes. And the sixth instance is the again the color is green, the toughness is hard, fungus is yes, and appearance is wrinkled, and the outcome is S. And this last instance is that orange, hard, no, wrinkled, yes. So this is the following data set we are going to consider as an example. Okay, let us consider the more specific hypothesis. As mentioned above, as mentioned in the previous slide, we can see we are going to consider the more specific hypothesis. In this, the most specific hypothesis initial is the 5. So you're going to consider according to the number of attributes. So we are going to have 4 attributes. Therefore, the 5 value will going to have 4. First, you're going to consider the first instance or the first data example 1. So we can see here that is the attributes are green, hard, no, and wrinkled. And this is our initial hypothesis is to be more specific. So we have to generalize it for this examples. So therefore the hypothesis for it will become H is equal to green, hard, no, and wrinkled. And we are going to consider the next instance or the next example. So that is the green, hard, S, smooth, but the outcome is said to be no. So therefore we are not going to do any changes as told in the steps involved. If it is a negative outcome, we are not going to consider. So therefore we can see this example which is having a negative outcome. So therefore we are going to neglect this example and our hypothesis is going to remain the same. So regardless of what is the attribute values for the no, but the values of the previous hypothesis will be retained. So that is H is equal to green, hard, no, and wrinkled. Then let's see the third instance, that is brown, soft, no, that is fungus is no, appearance is said to be wrinkled, but the outcome that is no. Again it is a no, which means we are not going to consider. We are going to consider previous hypothesis only be retained. So therefore this example is going to have a negative outcome. So therefore we can neglect this example and our hypothesis remains the same. That is H is equal to green, hard, no, and wrinkled. Let us consider the example 4. Here, the data present in example 4 is orange, hard, no, wrinkled, and the hypothesis said to be yes. We are now, since it is a positive example, we are going to compare the attribute value to the hypothesis value. So therefore, compare every single attribute with the initial data, and if any mismatch is found, we are going to replace with a particular attribute with a general case, that is question mark. So after doing this process, the hypothesis becomes question mark, hard, no, wrinkled. So this is possible by which the initial hypothesis we are going to have is green, hard, no, and wrinkled. But here we are having orange and hard, no, and wrinkled. All other attribute matches except the color attribute. So the hypothesis is going to have a green, but our example is going to have the orange. So therefore, since they are different according to the algorithm, we are going to replace it with a general case, that is question mark. So this is by considering the instance 4 or the fourth example. Next, we are going to consider the fifth example, that is the green, soft, yes, and smooth. Then now we are going to consider, we compare every single attribute with the initial data, and if there is any mismatch is found, we are going to replace that particular attribute with a general case, that is a question mark. So after doing the process, the hypothesis becomes question mark, because see, since it is a question mark, it does not have any comparison with the color, and toughness, here it is said to have the hypothesis is hard, but we are going to have the soft. And the fungus we have got here is no, but here the instance is going to have yes, and wrinkled, and this is smooth, that is the appearance. So all the attributes are have mismatched, so every attribute will be replaced with a question mark, that is the general case. So since we have already reached a point where all the attributes in our hypothesis have the general condition, example 6, we can consider the example 6, that is green, hard, yes, and wrinkled. But since we have already reached where all the attributes are for our hypothesis is a general condition, that is all the attributes when we compare, again we are going to get with the general case, that is the question mark. Since it has already reached that point, considering the example 6 and even the 7th example, it remains the same. So we can conclude that the given data, the final hypothesis would be h is equal to question mark for the 4 attributes. So this is how the algorithm works. Let's see the Python code implementation to find us algorithm. We can see here the code for the Python code, how it executes for the findus algorithm. So first you're going to have the function name as findus algorithm. We're going to pass a parameter as a training data. The function is going to take the training data as an input. So which is a list of examples as mentioned in the previous slide. So the training data, the initially what the instances, so that will be given as an input, and where each example is a list of attribute values which is followed by either yes or no. So which is followed by the outcome yes or no for each and every positive example, for each and every example. Then you can see here the hypothesis, it will be initialized with the first positive example in the training data set. So we can give the first example to the training data set as hypothesis is equal to training data of 0, which means this indicates that it is going to remove the last column, which is the label, that is the outcome column will be removed from this code. Then the algorithm initializes the hypothesis, the first positive example in the training set as mentioned. And the hypothesis is represented as a list of attribute, where each attribute value can be either specific value or it can be a wildcard, that is the question mark. Then the algorithm is going to iterate through the remaining positive examples in the training data set. See, we can see here that for instance in the training data, it is going to consider all the positive examples one by one in the training set. Then it is going to check if that instance of -1, if it is equal to yes, if it is a positive example. Then check for the hypothesis if it is consistent with the positive example, which means we're going to check each and every attribute value of the positive example to the hypothesis value. Then, for each positive example, the algorithm is going to check if the hypothesis is consistent with the example. If an attribute value in the hypothesis does not match the corresponding attribute value in the example and is not already a wildcard, then the algorithm is going to replace the attribute value with the wildcard. After iterating through all the positive examples, the algorithm is going to return to the final hypothesis. So we have to note that this is an Python code implementation for the positive examples data. So this is about the implementation of findus algorithm in Python. Thank you.